Good evening, I am Mr. Ish. Thank you for joining me for this video. We're here looking at the concept of cost. Yes, it sounds like a business or finance term, but it is very well relevant to maths and very well relevant to standardized test questions. The benefit of looking at this specific concept is that with regards to linear equations, it has quite a bit of application. Y is equal to mx plus b is a linear equation. Y is also equal to f of x. You can do f of x is equal to that. How can we talk about cost, which is the expense which a manufacturer incurs in producing products? That's cost. We can look at this right here, this component right here as TC, total cost, right? The total expense incurred in producing something. This component right here will be our variable cost. And remember, we're not going to get too technical here, so don't be worried. This right here is the amount of cost incurred in producing a single item. All right, let's just say cost per unit, the rate. That's exactly what we were talking about in the previous video. That's what we're talking about. This right here is called our fixed cost. The type of cost which never goes away and you always have to pay it no matter what. Whether you're producing something or not, this is the amount of expenses you have to pay, such as electricity, such as maintenance on your equipment, things like equipment breaking down, repairs, all of that, salaries for your workers, all of that has to be paid. When you're looking at something like this, you can also then say TC, total cost is equal to your variable cost per unit and the fixed cost. If you were to graph it out, let's graph it out like this. You have something which would look like that. A line over here, y equals mx plus b. From here to here, this little portion from 0 up to this y-intercept will be your fixed cost. We'll just abbreviate it as FC. Then, of course, if you draw it from here, this little portion to this little portion will be your variable cost. The extra cost or the expense you incur in producing each new item. This is the amount of cost you have to pay no matter what, whether you're making something or not, like electricity, repair, salaries. This is the amount you incur when you're making your items to sell. This from here to here then is your total cost. So keep all of this in mind. Our questions will be based on everything you're seeing over here. Alright, our first question has to do something here with regards to a car company, and this is their equation, and everything here is hypothetical. We have to analyze this equation. Y equals 8,000 plus 150x. What do we know right off the top? We know our fixed cost, which is synonymous with your y-intercept, right? This portion right here is equal to 8,000. It takes a certain $8,000 per month or per day or whatever it is per week to fund this manufacturing procedure. We know variable cost, which is basically the amount or the rate or the cost per unit, is basically, we're looking here at 150, all right? But this is like the amount of cost which is spread out over all the cars that are made. And then we know the total cost is equal to that. And if you were to graph it, you're looking at something like this. Here's your money, here's your quantity, the number of cars produced. You're looking at something from 8,000. Here would be 0, 8,000, and you have a graph which would go up like this, all right? That right there would be the equation. From right over here to right over here, which is 8,000 is your fixed cost. From here to here, looking here is your variable cost. The extra expense you incur for producing each new car, that's your variable cost. Then from here to here is the total cost. So a part of the question will be find f of 100 and analyze what it means. What does f of 100 mean? Well, you know, you're looking at f of 100 is equal to 8,000 plus 150 times 100, which you would place in x. F of 100 would very well mean what's the cost of producing 100 cars. You would run that x value right here to this equation. You'll do 8,000, right, plus 150 times 100. The cost of producing 100 cars, it's 23,000. Of course, it seems rather ridiculous. It's costing only 23,000, but this is all hypothetical. It could be like small children toy cars. It doesn't have to be even a large car. It could be one of those little cars which a kid sits into, like the motorized vehicle which you can buy from Walmart and you drive it around your house. That type of car, like one of those go-karts, 23,000. So the cost for this company to produce 100 cars is 23,000. Let's look at this as another part B. If f of x is equal to 30,000, find x. What does that really mean? It means that your entire equation is equal to 30,000, which means the total cost. All of this right here is equal to total cost. How many cars were produced to generate a total cost of 30,000? You're basically finding the x value. You have all of this right here is equal to total cost made of fixed cost and variable cost, which is equal to 30,000. You make the entire equation equal to 30,000 and you solve for that x and that will tell you how many cars will be made. Now, of course, I didn't make sure that we're not going to get a decimal answer, but that's fine. You can't have a decimal car, but we can roll with what we get. We have 30,000, right? Minus 8,000. We'll divide that by 150 and that'll tell us 146.66. We can round it up. This 30,000 represents that 147 little cars were made. And when 147 cars were made, it cost the company a total of 30,000. 8,000 of which were fixed costs, and the other was 150 times 147 to give you the variable cost. Remember, these type of equations represent total of a total cost, and they're made up of a fixed cost and a variable cost, and you can usually calculate this x if you know everything else. This is the portion which never changes, this is the portion which changes, and this right here is the portion which changes. As this changes, that will change. The second question of this video, I promise you a very wholesome and holistic experience. We have this information provided for a certain company that manufactures a certain item. We don't have to be too specific. We know the total cost is 10,000. The rate or the variable cost per unit is $190 per unit. We have to find the variable cost, the fixed cost, the equation if 40 units were produced, and we have to graph and analyze. It seems like we're asking a lot by providing you very little, but that's not the case. Think about it. Our equation is always y is equal to mx plus b. We know that the y here is always equal to total cost, and we know this part is equal to your variable cost, and that right there is equal to your fixed cost. We know the total cost is 10,000. We have that information provided. We know the m is your rate, which is your slope. It's 190. We have an x, and then we have a b. We have to find the b, and we already have the x provided. The x provided is right over here. This here is x, the number of units produced, 40. So you do 10,000 is equal to 190 times 40 plus b, and then b will be your y-intercept, which is your fixed cost. Do 10,000 minus 190 times 40, we get $2,400. So we know now our fixed cost here is equal to $2,400. What's our variable cost? If we know total cost is equal to variable cost plus fixed cost, then the variable cost is total cost minus fixed cost. Just take this on the other side, or just do mx. This right here is your variable cost. 40 times 190, that is your variable cost. 40 times 190, I get $7,600, and there it is. If you add 7,600 and 2,400, you'll get 10,000, and that will be true. We've produced a variable cost, a fixed cost. Now we have to generate our equation. Y is equal to mx plus b, right? Mx over here is 190x plus the b, which is your fixed cost, is 2,400, and this right here is equal to y. This right here is my equation. Now all we have to do is graph it and just analyze it, and then we'll be done with this question. It seems like it's a lot, but trust me, it isn't, because everything is breaking down into what an mx stands for: slope, the y-intercept, the fixed cost, the variable cost, and the total cost. Not too hard. Now let's graph it, and we'll try to be a little good with our graph. Here's 0, here's 10, here's 20, here's 30, here's 40. Why am I using 10, 20, 30, 40? Because 40 units were produced. This is my quantity of units produced. This right here is my expense or my cost. We know everything starts here. If x is equal to 0 and you're producing nothing, you still have this 2,400, because y is equal to 2,400. That's your y-intercept right here. 2,400, 0 comma 2,400, and then we know when we produce 40 units, we have a total cost of 10,000, and we'll make this 10,000 right over here. At 40 units, we have 10,000. We can connect this right away. Here's my equation: 0 comma 2,400, 40 comma 10,000, and at 40 units produced, we had a total cost of 10,000. From here to here, this is my fixed cost right here. This height is my fixed cost, which is 2,400. From here to right here is my variable cost, which is equal to 7,600, which are incurred as a result of producing 40 units. Is there ever a situation where you ever having a cost of $0? No, because your graph starts from right here. If you had 0 in place of x, you still have 2,400. Your fixed cost, your salary, your machine, your maintenance, your repair. No matter what, this is where you start. Then from here things only go up as you start producing items, because that's the beauty of fixed cost, is something you always have to pay no matter what. Variable cost is what you incur as you start generating more items. If this here is fixed cost, this here is variable cost, then from the very top I'm cutting into my graph, and to right here is my total cost, which is $10,000, and the analysis is complete. Remember, total cost, variable cost, fixed cost. This x is the number of units produced, which is right here your x-axis values. your y is equal to this, your total cost right over here, and the graph is done. And this question has been completed. If you have any questions, you can always leave them in the comment section. Thank you for watching. Have a nice day.